We want to talk about optimization of JavaScript. So how many people have actually thought about optimizing anything? Do we have people here who are not, maybe you're not a JavaScript developer, you've done C or C# or something like that? So it turns out optimization is one of those things that's kind of like the redheaded stepchild of programming. And very quickly I'm going to give you our itinerary. First we want to just go through a brief primer of what optimization is. I'm going to try and move pretty quickly through that because it seems like most of you raised your hands, so you probably understand the difference between trade-offs of space and complexity. Then we're going to talk about, well, why are we talking about JavaScript besides the fact that this is a JavaScript meetup, obviously. Second, we're going to chat through your friend, the engine. Whoa. The JavaScript engine, which to me is kind of a really cool piece of technology. Some of my background, I've done research at Georgia Tech in compilers, so some of my background is in that arena, so I'd like to chat a little bit about what the engine can do for us so that we can be a little bit more informed when we write our programs. Then I'm going to go through just a real quick basics boot camp, and finally I'm going to kind of gloss over some algorithms and patterns. And by the way, I'm really glad that I'm first because I would hate to follow up a telepresence robot. Alright, so what is optimization? Unfortunately, as I said, it's often very much misunderstood. People don't understand why we optimize things. Why should we do it? Why do we spend our time doing it? What's the most cost-effective strategy? When should we actually waste our time? Because there's plenty of times when I've been writing a program and it's just not worth the trouble of going through all the tiny little bits and bobs to make sure that I gain a microsecond or something insane like that. And there are a lot of myths that are proliferating in our industry, specifically around JavaScript. So I'd like to chat through some of that, and I'd like to focus a little bit more on best practices versus just the general deep dive into how do we optimize programs in general. So typical, this is CS 101. How many of you remember this? Typical optimization problems have two areas. What are those areas? This is the part where you say something. What are those areas? Right, so how much memory am I costing? Those are typically solved with smarter data structures. That's why we have the binary heaps and all those fun LRU trees, red-black trees, all those fun things. And then time, how long does it take? Well, that's solved with smarter programmers, with the algorithms that we build, like quicksort, merge sort, all that fun stuff that you remember from your CS courses. But inevitably, it all comes back to this argument. Every optimization problem I've ever attacked, they always bring this to the table. What is it? Premature optimization is the root of all evil. Donald Knuth, he's like the CS god. Well, let's actually look at what he really said. Programmers waste enormous amounts of time thinking about, worrying about the speed of non-critical parts of their programs. And these attempts at efficiency actually have a strong negative impact when debugging and maintenance are considered. We should forget about the small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. Yet we should not pass up our opportunities on that critical 3%, right? Very important context. So let's talk about the extremes. So on the left here we have the lazy hacker, probably just jumps on Stack Overflow, grabs whatever he can find and solves the problem. I'm actually guilty of this. I'm guilty of both of these extremes. I've done that thousands of times. When you got to ship something, screw it, I'm just going to paste what I find. Second, we have the over-engineer. That guy, by the way, is my favorite character, who just spends all of their time tweaking and tweezing and messing with the little pieces of code and taking variables and putting them in strategic places in the method like it's actually going to do something. I've done that before. As with most things in life, the truth lies where? Well, right in the middle. We need to understand how to make these trade-offs. And again, it is a trade-off in order to better inform the decisions that we make when we're building our programs. And it really boils down to this. Never attack an optimization problem unless you can prove without a doubt that it actually exists. But otherwise, again, that whole blue part that Donald Knuth wrote, strive to write intelligent code. And that's what this is about. I'd like to chat with you guys about how to write intelligent JavaScript. In general, use the 45-45-10. 45% of your time is spent finding the problem, 45% of your time is spent solving the problem, and the 10% is just writing the code, fixing it. Alright, why JavaScript? Well, number one, it's in very high demand. Number two, methodologies for writing performant code is not well understood, and unfortunately, it's not consistent across engines. How many of you have written something for IE8 only to find that it does not work everywhere else? That's typically the general idea, right? Everything in IE8 sucks, it never works. Thirdly, and this is kind of my favorite, this is a throwback to my Georgia Tech days with Professor Greenlee, is it's nearly sea-like in the capacity to blow both of your legs off. Not only can you blow one leg off, but you can blow both of them off. Not only can you write a really slow program, but you can also write a program that takes up 2 gigabytes worth of your computer's memory in Chrome, all right? Really big issues there. The intricacies of memory management, they seem like they're difficult. I don't know how many people here are novices to JavaScript or how many are more of the deep dive where you really understand like closures and scoping and how all of that works. But it actually takes a good bit of practice to figure out how to really write closures correctly so that you're not leaking memory all over the place. Even with modern MVC frameworks like Angular, Backbone, all that cool stuff, which are fantastic frameworks, business logic doesn't write itself, and it has to be written well, right? You can't have this nice pretty framework and all of a sudden you got a triple for loop in there doing something stupid when you could have just done it with a regular for loop and a hash map, right? The particulars, and this is my favorite one, this is where this has shot me in the foot more than once, is the particulars of how you interact with the DOM can really slow things down to a painful degree. And that's some jQuery tricks, so I'm not actually going to go into those. So let's chat about the JavaScript engine. It's your best friend. It really is. JavaScript runtimes are way, way, way faster than they used to be. And there's tons of them out there. There's SpiderMonkey, Chakra, Chikara, however you say that. V8, Nitro / Squirrelfish, all of those are implementations of sort of the same EMCA standard, right? We have this body out there that invents standards, and those standards are then implemented by other people, and that's why we have all of this crap. That's why we have 5 different implementations of this. So, this is really cool. A lot of the breakthroughs in JavaScript performance were tricks that were learned from other runtimes, like just-in-time compilation. Base compilers, so whenever you feed your program into the runtime, it's going to run a base compiler on it. That compiler is going to take that JavaScript and it's going to translate it straight to machine code, or it's going to take it to some intermediate language that's typically a bytecode representation. You can think of a bytecode as just a step above assembly. Does everybody know what assembly is? It's like a very, very low level that the computer just speaks. Well, that IL is a little bit higher, and you can do some fun things to that IL. That's the reason why in compilers we actually have that extra layer in between the computer and the high-level language, is so we can play with it and do cool things like constant folding and all these other things that I'll talk about. This is the most important thing: hot function type and JIT optimization and backout. We're going to talk about backout a little bit and when you can trigger a backout. It's extremely expensive when you write a program that possibly optimizes a function a lot, but then all of a sudden you do something in your program that confuses the runtime and it backs all those optimizations out. It's like a cascading failure. It causes everything to be very, very upset. And method inlining, what that is it simply takes the body of the method and it copies and pastes it into the place where the method is called. So if you have like an alert hello, for example, and let's say you have a function that calls alert hello, and you have maybe another function that calls the function that calls alert hello. I know that's confusing, but follow me. It will actually copy the body of that function into the first one. All right. Sorry, that was very confusing without an actual piece of code to look at. My apologies. So this is important to efficient garbage collection using the ubiquitous mark and sweep. So all JavaScript runtimes, they do garbage collection just sort of the same way that a JRE or a .NET runtime does. Which is good because it means that it's going to act the same way, but it's also one other bad thing about garbage collection, and I'll talk about this later, is that you can't actually force it ever. So that means you have to be very smart on how you write your scoping and your closures. Constant folding, dead code elimination, and other lightweight optimizations. This is stuff that typically only happens if you have an external compiler that you can run on your JavaScript. I think Google Chrome or V8 has this external compiler that you can execute that minifies and does all kinds of fun things. They've actually started implementing in research circles some of the more complex constant folding algorithms and dead code elimination stuff that you get in a normal statically typed language. Extremely rich profilers, very, very cool. You need to learn how to use your profiler. If you don't know how, that's a really good place to start. And finally, and quite possibly the one thing I want you to take away from this entire presentation, if you forget my name and forget our cool tacos, is the internal representations of compile code are called hidden types, okay? We'll look at this more in depth, but this is what will kill you for performance. All right. So, let's talk about the basics. Not everything will work with every JavaScript engine. Everyone's run into this. In general, you need to trust your best you need to use your best judgment along with careful examination. Trust the data before the intuition. So when you're executing your code and you think that function over there is causing a problem, well, do you have data to back it up? This goes back to the golden rule. And finally, this is an interesting website that I found. You guys probably all know about it, but If you're unsure if your implementation will actually be any faster than the way it's currently done, you can benchmark it by just hitting up JSPerf. And there are tons and tons and tons of benchmarks that folks have already done on JSPerf.com to compare, for example, I don't know, a prototypical inheritance model versus the module pattern. So this is really good stuff. If you just Google it or Google Osmani, anything to do with that guy, he's got tons of JSPerf projects up there that you can look at. All right, so I put this up here on purpose to incite a riot. Why did I do that? Because this is extremely subjective, okay? I found this on the internet, and it actually is a little bit faster. There's a JSPerf out there that proves that in a tight loop, using join on an array of strings, you see the join down there, versus just simply doing the plus sign is faster. But in this particular instance, if this is just like a message box that goes on an alert somewhere, does this really matter? That's a question. Does it matter? Why doesn't it matter?
It's only going to get called once.
Exactly. It's only going to get called once. Who cares? This is the meticulous guy. This is the guy that just wants to be very, very correct. And there's nothing wrong with that, all right? We've all worked with that guy. And that guy is awesome, and he does good things for us. Sometimes he's a little frustrating because he'll change my code from A to B just to be a jerk about it. But nevertheless, this won't really matter in the long run. And that's the big thing I want to highlight, is it really is about the context in which we're looking at these things. So this actually might matter. Why might it matter? Exactly. We've got a tight loop. What if 20? What if that was n? What if that was 100,000? What if that was a million? We're basically concatenating a million. Well, first off, you're going to lock Chrome up if you try and compute a million Fibonacci numbers. But second, it's needed in this specific case because we can prove it's a problem. If you were to benchmark this, you could tell that with the string concatenation, it's going to slow down. Right? Cool. So let's move on. Hidden classes, what are those? We mentioned them a little bit earlier. Virtually all JavaScript engines, every single flavor, they represent objects as hidden types or hidden classes behind the scenes. Okay? This enables many optimizations because you can make strong assumptions around the data that you're working with. If you think about JavaScript, when you're sitting there writing your code and you're just banging away and you create a brand new object, you open your curly brace, I'm going to make a custom object right in the middle of my code, then the runtime doesn't really know anything about that until it executes that code, right? So pretend you're a JavaScript runtime. Pretend you have to figure out how to make everything go really, really fast, yet you don't know what you're going to get until you get it. Kind of a hard problem to solve, right? So many elements in a JavaScript program will have a hidden class, not just objects that you create, like this point object that we have here, but also function parameters and even functions themselves. And that can inform how we write our programs a little bit. So here's some quick guidelines on how we actually want to work with hidden classes. Avoid modifying the structure of hot object runtime. This can trigger a deopt, which is really not good. As we said earlier, it's kind of a cascading failure because the runtime has to reconfigure itself and figure out what went wrong. This example here, let's run through it real quick. So we create a new point, we have an x, we have a y, then we call 2 points, but then we randomly just add a z on top of our point. Well, then P2 is no longer a point. When you were running this JavaScript, the runtime engine figured out what a point looked like. And it saved it in memory in some special way, okay? Because remember, these things are just, all they are programs that handle memory, right? It just boils down to creating IL and other things. Right here we go to P1, we go to P2. Oh, okay, great. I know what a P2 is. It's the same thing as a P1 is, so I'm going to represent P2 with the same hidden class. We hit P2.z, oh, that's different. So now I have to undo all of the assumptions that I had about P2 in order to make it actually line up with what's really happening. If you use constructors, so that kind of boils down to these other 2 little points here. You want to use constructors when you create new objects instead of doing the curly braces if you can. And initialize all the fields in the same order. Because what that will do is that will allow the runtime to make more strong assumptions about what those objects look like. And for hot objects, keep the prototype chain simple and keep the field count low. The more fields you have, the more assumptions we have to make about that object. Any object, property, array, or function parameter is subject to having a hidden class. So you want to keep these things from changing as much as possible. You want to keep your functions monomorphic, and you want to modify the structure of these entities as little as possible. So what is a monomorphic function? Well, I've got a quick example right here. Function add x and y, return x plus y. Because the way JavaScript is, it's a typeless language, we can actually do this, right? That's cool. It'll just return A concatenated with B, because the plus sign works with both numbers and with strings. However, what that will do is that will cause these two function parameters here, because remember, everything is subject to having a hidden type. These two function parameters will now have a really screwy hidden type. We won't really know what it is if it's always a number or if it's always a string. So one thing you can do to solve this problem, again, if it's a problem, is you create two separate functions, one for adding strings and one for adding numbers. That way the runtime can make strong assumptions about the inputs that it's getting into functions. Memory management. I'm going to spend a little bit more time on this than another one because this is probably the most important piece. The golden rule, don't hold on to objects any longer than you need them, because garbage collection can never be forced in modern runtimes, and you probably wouldn't want to anyway. In general, the runtimes are smarter than we are, and you should make that assumption in general. Never use delete, because delete will do what? It'll modify the hidden type, and then we trigger a deopt, and the whole world goes crazy again. And finally, I've done this before, I don't know if you've done this, but nulling a property actually doesn't do anything in most runtimes. So avoid it in general. So how many of you know to avoid globals? How many of you use the module pattern to avoid globals? Good. Module patterns are great for avoiding globals. Global namespaces are only cleaned up on page navigation, tab destruction, or when the browser is closed. So if you put something really, really large in a global namespace, you are going to suck up memory and make your user very, very angry. I do not recommend that. We also want to avoid creating unnecessary closures. Instead, make hot functions static and make sure they're defined outside of the class. So I've been saying this hot thing a lot. I want to go back and explain it again. Remember, it's only a problem if you can prove that it's a problem, right? If something is hot, then that's something that's been executed many, many times in your program. So you need to pay attention to those things. Loops. Anything that's in a loop is subject to being a hot function, right? Here's an example of how to avoid this problem of having an unnecessary closure. So what do we have? baz.bar equals a new function. This.foo equals function, yada, yada, yada. Well, this creates a closure, right? You can avoid this entirely by simply doing baz.bar equals function and then use the prototype to slap the function on the prototype. Bam. You avoid the unnecessary closure. Very simple. This is a good one. How many of you have ever done a timer leak? My wife is raising her hand. She has not ever written a timer leak. So, timer leaks are very, very nasty. And this, again, is one of those places where you have to be very careful about the scoping of how you're writing your program. Why is this a timer leak? Can anyone tell me why this is a timer leak?
Because you're calling the function that sets the timer within the timer set.
Exactly. So it's a circular reference, and it will forever hang on to itself. And it will forever spin and forever do things. Perfect. Another good example is this large string, this new array of 1 million characters. Guess what? That's going to hang around forever. Because the closure keeps returning it, right? So whoever gets it, whoever hangs on to it, will have it forever. So, imagine if you have, large pieces of JSON that are hanging around in your project because you want to, keep up with maybe stock data or something cool like that, maybe baseball data. And then all of a sudden you write something like this and it hangs around for forever, or you get multiple of them going on, then again, you're going to have a 400 megabyte Chrome tab and people are going to be very upset. So this is why we have to pay attention to these things. All right. I am actually going to skip this. I'm going to go really quickly over this because this part is not super relevant, but just in general, the idea is only iterate over index types, because if you start iterating over objects, it's actually really, really slow. And use copy constructors when you're creating large objects. That's more or less it. That's stuff you can Google if you want to know. This is the big one that I wanted to get to. So those of you who are jQuery gurus have probably written something like this before. I remember when I was learning jQuery, I wrote the top one. And I wondered why it was slow, but I didn't care because it was for a class. And I just threw the code away anyway, and I never bothered finding out why it was slow. But now I know why it was slow. Can someone tell me what's wrong with this top one?
You're rendering every time.
Bam. You're rendering every single time. You're triggering what's called a repaint and a reflow of the window. So it turns out the browser has this paint loop. And for those of you who have done Swing before, maybe you remember the paint loop in Java. The browser has a paint loop that sits there, and anytime something changes on the DOM, it re-triggers the paint loop, which reflows everything, and it has to do a lot of hardcore calculations in order to figure out where everything goes. Well, that's why you don't do stuff like this. I am now triggering a reflow in a loop, which is a very, very bad thing. If you run this on your browser, it will lock it out. The way to solve this is simply kind of the same. You just store a temporary variable, right? It's not that difficult to see. We create a temp variable, and then we iterate over everything, and we just keep adding it to the temp variable until we're done, and then we append it once. Append as few times as possible. That's the general idea here. Cool. So choosing a structural pattern. How many of you know what module versus prototype? Is anyone familiar with this kind of religious holy war? Yeah, so there's a big, huge holy war on, is module better than prototype? Well, actually it turns out, thanks to Osmani, the JavaScript god, he did a performance on it right here, this JSperf link right here. There's actually no difference, according to him anyway. Some people will probably still fight on that, but whatever. From my perspective, what I would like you to take away from this is really you should balance speed with personal style. If prototype is 2 milliseconds slower, but it gets you a better look and feel to the code so that folks can understand what you're writing, then I would recommend that you go with the one that makes people understand it. Because when we're thinking in terms of maintainability, in all honesty, obfuscation of code becomes a waste of time. Because we're passing this code off to other developers, and you have to make sure that your code is communicating what it is that you want it to do, instead of just being, oh look, cool, I use this really awesome pattern that nobody knows what the hell it does, but yet it's really, really fast. So using template engines as well, they're all about the same. Mustache Icon has all of the same. They do kind of the same thing, JS Render. So you really want to pick the one that gives you the best architectural perks, that gives you what you want to do. Prefer external libraries to handwritten code for common problems. Use Lodash. How many of you use Lodash? Underscore maybe? So there's underscore and there's Lodash. Lodash came after underscore, but that's random trivia for you. They both do the same thing. And they're really good libraries, and they've been tested rigorously. And they won't have any memory leaks. And finally, know the strengths and weaknesses of your MVC choice. Know the difference between Backbone and Angular. If anyone's been to the todos.mvc website that Osmani wrote, it's really awesome. You can just jump on there and click literally checkboxes of what kinds of MVC frameworks you want to kind of cobble together into one piece, and then you can run it and see how it works. Highly recommend that. So I'm going to talk through memoization real quick. How many of you have read JavaScript, The Good Parts? And how am I doing on time? Am I doing on time? Good. 15 minutes? Okay, awesome. So JavaScript, The Good Parts, kind of ironically, it's about that thick, whereas the JavaScript manual is about that thick, which tells you something about JavaScript in my opinion, but that's okay. Memoization actually comes from dynamic programming, which was invented by Richard Bellman. Who knows who that guy is? He wrote the Bellman-Ford algorithm, really smart dude. He was a researcher. He actually came up with the name dynamic programming because a bunch of senators wanted to know what he was doing, and he just invented it. He was like, yeah, we're doing dynamic programming. And when asked why, he said, well, because it sounded cool, and because I doubt that the senators would have funded research. So I called it dynamic programming. It's hard to find useful applications of this outside computationally iterative or recursive functions. So I haven't really seen a lot of this in the wild for JavaScript. It's actually really big in scientific computing and things of that nature when you want to remember what you've done before, which is kind of the whole point of it. And it doesn't work if your function is non-deterministic. All right? So I've got an example here, and I actually want to show you a quick, cool implementation that Osmani did of a cloth that's hanging, and he wrote it with memoization. We'll take a look at it. It's on a canvas. Functions that are eligible for memoization must be referentially transparent, which means that they have to depend on their inputs. Whatever you get on the input, that's what you have to depend on, right? You can't do some weird computation and expect it to memorize properly. The generic implementation is here. You can actually Google this. This is just boilerplate. You can copy it. But right here is the important part, var result equals fib of paren. You would replace fib with the function that you're interested in. Or you can, if you want to get fancy, you could even pass it a function in a closure. And you could execute that function, for example. And finally, again, we're going back to our original mantra that the overhead of caching may not be worth it if it's infrequently called, right? Unless it's a computationally efficient or computationally heavy portion of the code. And I'm going to show you this really, really cool demo real quick. Assuming it works. All right. This is on an HTML canvas, and it is done only with memoization. Pretty cool, huh? Each point remembers the previous point, it remembers where it was, and all the other points simply compute themselves based on the point that you grab. And you can look at the code and check it out. It's actually not a lot of code to do something cool like this, right? Just using something simple like memoization. Pretty neat. All right. So we're almost done. Let's chat real quick about algorithms and patterns. I actually haven't run into many places where I've needed a hardcore algorithm in JavaScript, and therefore, I guess, not many other people have either, because there's not that many patterns, there's not that many libraries out there. I don't know, does anyone know of like maybe a scientific computing library in JavaScript, or something that does like, I don't know, quicksort or something like that? See, exactly. So that must mean it's not used or it's not needed, which is fine. But if you are starting the next cool startup in Atlanta and you just so happen to come up with a really cool algorithm that you want to implement in JavaScript, well, you can use some of these things we've talked about to make it really fast. Because in all honesty, the only time you're going to need stuff like this is when you're focusing on a portion of code that's heavily executed, or when you're focusing on memory management. So if you have a very large framework, which Angular and all those MVC frameworks sort of handle memory for you for the most part, so you don't have to worry about it. But if you had some sort of custom piece of code that you had to write, you had to be memory conscious. Most design patterns that I've seen thus far, they're all designed to kind of optimize memory footprint and the readability of your JavaScript code. Because, I mean, let's be honest, JavaScript is really irritating to read, as it is to me. It's hard for me to understand what's going on sometimes. So all of the cool patterns, like the module pattern, are set up such that it's easy to understand what's going on with the facades, the modules, and all these other cool organizational patterns. And finally, it's especially crucial to pay attention to hidden classes if what you're writing is computationally intensive. All right, so my parting words to you, and I'll take a couple of questions if that's cool. Number one, write intelligent code, right? Work smarter, not harder. Second, use frameworks. There's no need for you to roll your own stuff when most of the stuff that's out there has already been performance tested and it works really, really well. Number three, be especially mindful of memory. Again, nobody likes 600 megabyte Chrome tabs. And finally, profile, profile, profile. In general, it is not a problem unless you can prove it. All right, any questions? Fire.
In terms of profiling, like, you know about the Chrome tab, but what are the best tools to use?
So if you're working specifically in V8, V8 has a very rich profiler tool chain. You can hit it via command line on your Mac. You can hit it via command line on your Windows box. Just basically Google that and go look at the docs for that. Chakra, which is IE's engine, also has a similar profiling tool set, but they're not quite as far along as V8. V8 is definitely the most featureful JavaScript engine. I would recommend you probably test all your code there first, and then just port it back to wherever you deal with the idiosyncrasies of Apple and Microsoft. Good question. Yeah.
So I was surprised to hear you say about not deleting properties or nulling them out. When you have a global object and it is referencing other instances, how else would you make those instances available for garbage collecting besides deleting their properties or nulling them out?
Right, good question. So in general, the way you solve that is have a different structure to your program such that you might not need that. You can, I mean, again, profile, profile, profile. If you are deleting something on an object somewhere and it does not slow your code down, then by all means ignore what I have to say. I'm perfectly cool with that. However, do know that you will trigger a deopt, and that might actually slow things down. You may not ever see the deopt, so that's kind of the tricky part, because the runtime may or may not decide when it needs to trigger that deoptimization and completely cascade your whole JavaScript program in the runtime, and everything gets really tricky there. But the way I solved things like that in the problem in the past is have much smaller objects that communicate with one another, or have more of a dependency injection style hierarchy, where when you're done with it, you don't need it anymore. It just kind of falls out of scope. But it's definitely a really good point. Yeah. Anybody else? Cool. I'm done. Thank you.